Hi everyone. Thanks for attending our monthly webinar. Today, I'm going to talk to you about how you can use Okareo to evaluate your agent's function call capabilities in a production environment. Let's get started. So first, an introduction. My name is Mason Del Rosario. I'm a founding staff machine learning engineer here at Okareo. I completed my PhD at UC Davis in applied machine learning in wireless communications networks. And I've been with the company since about February of last year, so a little over a year now. Before we talk about agentic function calls, let's start by defining this buzzword of agent. I'm sure you've heard lots of different definitions about what makes a system agentic. You've probably seen lots of different terms and charts floating around on social media about them. But for the purposes of today's talk, we're going to think of an agent as a language model, so a LLM, that can interact with the world. And the mechanism by which the LLM interacts with the world is a function call. So let's give a few examples of different types of function calls that an LLM might make use of. One such example is an API call. This type of function call will let the agent interact with other apps in order to get or change the state in the application. So here we have an example of using this send email API with a few body parameters, such as subject, a meeting request, body for the actual email. Are you available for a call being sent to this recipient of John Doe? Another example of a function call that an agent might use is code execution. Now, I'm sure you've all seen this strawberry problem pop up maybe a few months ago now, where people were typing into, say, ChatGPT, how many R's are in strawberry? And it turns out the model was pretty bad at answering this question. It would confidently state that there are 2 or 4, never the correct answer of 3 R's. And if we were to give a model a code execution function call, then the model could pretty easily put together a short 1-2 line script that can just sum up the number of R's in the string strawberry and then happily report back with the correct answer. So a code execution agent could make quick work of this strawberry problem. Finally, another example, and probably the most powerful example of function calls, is actually giving agents the ability to invoke other agents in order to plan, delegate, and assist on tasks. So in this example, we might have a manager agent, and the manager receives a request for the history of oil prices in OPEC countries. The manager agent might not have the right context or function calls available in order to get that context. So that agent can invoke an analyst agent that might have those function call capabilities in order to get a report on the 10-year history of oil prices in OPEC countries. And then the analyst, using its function calls, which might be some RAG tools, can get the proper context, write the report, and happily pass that back to the manager. And then finally, the manager can summarize the contents of the report and return that to the user. Now, while function calling is great, and there's all sorts of different things that we can do with it, how do we know that any given function call that an agent is making is actually good? One way to do this is with reference-based evaluations. So let's start with a simple example. Let's suppose we have this input here where a user is asking for the top comedy movie. This input might come in to our agent, and the agent might have this search movies function call available, and it specifies the genre of comedy. And if we're conducting a reference-based evaluation, we would need an expected function call. So here, our expected function call, or our reference function call, is a search movies function with this genre parameter equaling comedy. With the generated function call and the expected function call, we can evaluate the agent's function call capability as either correct or incorrect. And in this simple example, we can pretty easily identify the function names correct here, so search movies, and the argument genre also has the correct value. So in this situation, we would label this result as correct. Now, reference-based evaluations are a pretty hot topic when it comes to the LLM research community. And for example, there's this team out of Berkeley that developed a language model called Gorilla that is open source and based on a variant of Llama. And they spent a lot of effort into maximizing the model's function call capabilities. In order to benchmark Gorilla against the whole world of other available LLMs, they needed a data set. So you could think of this as an evaluation data set or a golden set where they had reference queries and expected function calls in response to those queries. So this left diagram is the so-called Berkeley Function Call Leaderboard, or BFCL for short. And this is updated regularly whenever a new LLM comes out and the Gorilla team decides to benchmark that LLM on this golden set of data that they've scraped together. The Gorilla team, in order to actually put metrics on this table, needed to decide what metric they would use. So they needed to decide the mechanism by which they decided a generated function call matches a reference function call. And so this right diagram shows one such methodology that they landed on. This is a decision diagram for a so-called AST, or abstract syntax tree based reference metric that they implemented. So this allows them to exhaustively determine whether a generated function call matches a reference function call. They check for the function name matching. They check that the required parameters are present, that there are no unexpected parameters, and that the types of parameters match. And then finally, that all the parameter values match. So to help our users evaluate their function call models in development, we've taken this AST reference match check, and we've provided it as a predefined so-called check in Okareo. Now, this is a lot of words. Let's look at how this actually looks on our platform. So this is a small evaluation that I ran on the BFCL Gorilla dataset. I've got a few rows of data here, and I'm using the AST validator that's been provided by the Gorilla team. And if we want to get a little bit more detail on exactly what this check is doing, then we can hover over here and just see a short description that we're providing to you. So we see that this validates function calls using the simple AST checker from the Berkeley Function Call Leaderboard. The tool call in the model is compared to the expected structure in the scenario result. So that's the reference result. We could go ahead and click into one of these rows. So here we see that this check passed. So the AST validator gave us a positive result. We can click in and take a look at the actual row, and we can see the input query. So here the user's asking about an audio file they want to analyze, and there are a few numbers in here as well. So we have a percentage of 70, and we have a confidence window of 0.8 seconds. We also have the expected result that corresponds to this query. So there's a function called detect beats and filter. And there are two arguments of capture percentage and confidence window size. So we can go ahead and check out the actual tool that was invoked. And we see that the name is matching here, the detect beats and filter, and the parameters also appear to be matching. And as a result, the function call AST validator check passed on this particular row. We can also check out an example where the check has failed. So in this situation, the user humorously asked to buy a pizza from McDonald's. And the expected result here appears to be an Uber Eats order function that would presumably be called against the Uber Eats API. And the arguments include McDonald's, and the items and the quantity appear to be lists. So here we're asking for one pizza from McDonald's. And in this situation, the model, so GPT-4 Omni Mini, I believe, came back and said McDonald's typically doesn't serve pizza. And it actually didn't invoke any tool calls. So in this situation, the function call AST validator check actually fails. Now, reference-based evaluations are great for developing your model on an eval set or a golden set, but they're not exactly applicable whenever we're operating in a production environment. And to illustrate this, just consider what's going on in production, right? User queries are coming in. We're happily generating function calls in response to those queries. And we get to our evaluation step where we want to say whether or not it was good or bad. Did it pass or fail? Well, we can't know a priori what the expected function call should be in response to a given user query. And so what might we do in this situation? One thing that we've landed on here at Okareo is to use language models to help evaluate the function calls that are being generated. So in this situation, in addition to this agent that is generating the function calls, hypothetically, we could set up another agent that has a large prompt that is priming the agent to evaluate incoming function calls. So here, there's just a brief header saying, you're an expert judge. Your task is to evaluate the following function call based on the following criteria. Doing this, we can have another agent inspecting the function calls that our other agent is creating, and we can evaluate those outputs, those function call outputs, as either correct or incorrect given the current situation. This provides us with an automated method of conducting reference-free evaluations on production data. And so on Okareo, we've enabled both these LLM-based checks and the code-based checks that we looked at earlier on the platform. We already reviewed one way that we can use code-based checks to deterministically evaluate your agents against data from a golden set that has labels. And I'm going to show you very shortly how we can dynamically evaluate agents on unseen function calls using a LLM-based check. So let's go through a demo on how this might look for an actual developer who's developing an agentic application. So today I'm going to show a chatbot application built using the Vercel AI SDK. And this is just an SDK for Next.js apps that has a support for a variety of LLM providers. The provider that I'm going to use today is OpenAI, and I'm going to make calls against GPT-4 Omni Mini. So I'm giving GPT-4o here access to a few tools, but the main tool that I care about is this get weather tool. And let's say we have a user coming into our app and they're asking for the weather in San Francisco. My chatbot should invoke the get weather function call. And in response, we should get back a JSON body containing a lot of information, including the actual weather in San Francisco right now. And finally, my chatbot, the assistant, should summarize this information and present it to the user in a user-friendly manner. So we've already instrumented this chatbot application with Okareo so that the chatbot's completions that are getting requested from OpenAI are getting sent via OpenTelemetry to the Okareo platform. And by doing this, we can gain some more insights into the inner workings of our chatbot application. So without further ado, let's go ahead and check out the app. So here, this is the chatbot application that I have forked from a repo on the Vercel AI SDK GitHub repository, network of repositories. And I'm going to go ahead and click on this request here. So I just want to know, what is the weather in San Francisco right now? So the model thinks, and here it's gone ahead and called a tool and rendered the results of that tool in a nice user-friendly format. And it also summarizes the response here. Now, this is great as an end user, but if I want to get more insight into what's going on under the hood, it'd be really nice if I could see the actual completions that the app is emitting. And as I mentioned, we've instrumented the app with Okareo so that we can actually view the sequence of completions in a more raw format. So over here, I'm now in the traces page of Okareo, and I'm looking at all of the data points that have come into Okareo. The most recent completion should be right here. And let's go ahead and expand that a little bit. So this is a completion that has access to the get weather tool. So this seems like the right place to be. This is the tool that I care about in this situation. And we also can see the system prompt that we gave to our chatbot app. There's a lot of boilerplate stuff here, as lots of system prompts tend to be. And we can also see here the actual user prompt. So we did ask for the weather in San Francisco. It's good to see that that's here as well. So rather than seeing just that nice front end component, we're actually seeing the raw tool call that the model invoked, as well as the result here. So we called get weather, and we called it at this latitude and this longitude. And we can go ahead and scroll down a bit and see that we're getting a lot of information about the current weather in this latitude and longitude. And here, after the tool result, we can see the summarized version of this data. So the model picked out the temperature, and it politely let the user know that we can ask for more information. So this view is great in order to see the raw results of completions from an application, but this can be a little overwhelming. I don't know how many of you have actually spent some time developing one of these apps, but you can start to see a lot of completions piling up if you're experimenting in development, but in production, you might see even more completions coming through. So what we're going to do is we're going to set up a monitor in order to filter down to a subset of completions. And we're going to attach one of our LLM checks to this monitor in order to help us identify problems in our completions as they come in. So I'm going to choose to add a filter. And I know that in my app, I have set a few fields. This function ID field is one that I'm keying in on. I have assigned it to the various functions in my Vercel app. So I'm just going to look and see if that's set. So we can actually instantly see that we're filtering out some of the data based on this filter that we've applied. And just because I only care about function calls, I'm only going to look at completions where tools are made available to the chatbot. So here I have tools available, and I'm going to click on is set as well. So in order to save this and apply checks to completions that land in the monitor, I'm just going to click over here on Save Trace Monitor. I already have the name populated here of weather chatbot, and I want to find a check that applies to function calls. So in order to do that, I am going to pop over to the checks page of the Okareo app, which is right here. and I'm going to look for function related checks. And I see this one here called function parameter accuracy. So it looks like this one ensures that extracted values from the dialog are correct and max expectations. That sounds great for my application. I'd like to know whether or not the get weather invocations and the parameters, the latitude and the longitude in this case, actually make sense for the given cities that I'm requesting. I'd like to know some more information about this check. So I can actually click on the name in the table here, and I can get the full template that Okareo is using under the hood in order to run this check. So this is actually the result of a lot of experimentation on our part. And this includes some best practices from different papers that use large language models in order to evaluate completions from other language models. But just summarizing it and briefly looking through it, we can see that we're setting up the evaluation criteria, and we're asking the language model to evaluate based on function call parameter sufficiency. We tell it to give a pass fail, and we provide some important guidelines on how to think about what's a pass and what's a fail. And we also set up some evaluation steps. Importantly, we are providing the available tools to the check so that the check knows these are the tools that were available and these are the parameters for each of those tools. And then we provide a few examples of what types of responses we expect. And then finally, at the very end, we pipe in the tools that are available, the actual sequence of messages in the completion, and the tool calls that were invoked. So that's all to say, I can go to this table and I can get lots of information on what checks make sense for my current application. And in my current application, I think I want to use that function parameter accuracy check. So I can go ahead and save this monitor. So the monitor starts out with no data points in it, and I would like to see some data points in there. So let's try that same completion again. So here I'm asking for the weather in San Francisco, and we get a response that looks largely the same as before. We can pop back over to this tab here, and we see that we've gotten a few data points that have trickled into the monitor. That's great. We can click in and we can see that 2 data points have been spawned from that last interaction. And clicking in here again, we can see it seems like everything's great. So the check, in addition to having a pass fail value, also provides an explanation as to why we gave the pass or the fail score. So in this situation, the function call to get weather includes latitude and longitude parameters for SF. So that's great to know. We don't need to spend a ton of time trudging through all of the various turns of this conversation to figure out what's going on. Great. So we were able to get this instrumentation working for a pretty simple interaction in the app where we're just asking about the weather in San Francisco. And we've set up a monitor and a check in order to help us kind of keep tabs on what's going on in production. And at the moment, the check is passing. Everything's nominal. All is well. But let's see what happens whenever something goes wrong. So here, let's say the user's asking for a bit more. They don't just want the weather in one city. They actually want to, say, plan a trip, and they want to know what the weather is in multiple different cities. In this situation, we are going to expect a parallel tool call with multiple invocations of get weather. And we are going to expect a summary coming back of those 10 cities and the weather in them. So let's switch back to our app and try that prompt out. So here I can ask, let's see, can you give me the weather in the 10 largest cities in Mexico? So we would expect to get 10 results back. And it seems like at the moment that's not happening. So even as a user, I can kind of tell that there's a problem here. And it also seems like the app is still thinking. It spat out a moment later more completions, so probably more weather locations. And it looks like we've got some results back. So here's the current weather in these 10 largest cities in Mexico. Great. So we had some end user funkiness. Let's dig under the hood and see what actually happened in these completions. Okay, so it looks like Okareo has detected a few issues in this application. So let's click on the latest one to see what's going on. Now, normally, if I didn't have any checks available, first off, I wouldn't have even clocked this particular completion as problematic. And I probably would have had to open it up and use the method of concentrated staring in order to look at each turn of the conversation and see if something's up. But frankly, as I scroll through this, there's a pretty long message history. The individual messages, the tool results especially, are quite long. And the fact that I just asked for 10 rather than just one completion tells me that there's something pretty wrong going on here. So rather than trying to sift through all the completions manually, I can use the explanation in order to guide my debugging analysis. So it looks like the user requested the weather for 10 cities in Mexico, and that the assistant made multiple calls with specific longitude and latitude. But the assistant made duplicate calls for some cities, for example, Mexico City, and didn't ensure that all 10 unique largest cities were covered. That's interesting. So now I can go down and I can key into the list of tool calls that was made right here. And we can look at the latitude and longitude values. And it looks like there are a few duplicates in here. So we want to get the model to avoid this behavior and to not try and just shove in whatever latitude and longitude values it cooks up on its own. So in order to do this, I'm going to give the chatbot a new tool called Think Before. And the hope is that it makes this function call prior to invoking the tool call with the list of get weather calls, and it will improve the quality of the final result. So let's go ahead and do that. So here in the app, I just need to comment out a few lines that enable the chatbot to use the think method. So I'm going to go ahead and delete some of these conversations, and I'll start a new one. So I'm going to use that same prompt. So can you give me the weather in the 10 largest cities in Mexico? So here, the chatbot is thinking for a moment, and it might take a moment since it's planning, but it appears that it's had a thought. So it's used the think before tool. And importantly, it's strategized beforehand, and it's thought up what the 10 largest cities actually should be. And it's come up with a short plan in order to execute. And here we see it's invoked the tool, and it's gotten the data, and it's now summarizing that data. So we don't know necessarily if the duplication of latitude and longitude values actually happened in the completions, but we can figure that out in Okareo. So let's go back. So let's look at all the completions that came in. And it looks like we're still working through some issues here. It appears that the user requested the weather for the 10 largest cities in Mexico. Sorry. I had a bit of a delay in those data points trickling in. That was I could recognize that explanation was a duplicate. So it actually looks like this time, the function calls to the get weather tool include the latitude and longitude for each of the 10 largest cities in Mexico. We can pretty quickly verify that this is the new completion by seeing that the thought tool was invoked. it looks like here we've gotten the contents that we saw earlier, and then the tool was invoked, and we have unique latitude and longitude values being used. So that's great. We've given the model a new tool, and we've set up a little harness in order to verify that we're getting the right responses. And so just some closing thoughts after this demo. Today, we've shown you how to evaluate your function calling agents in Okareo, whether you're in development or production. And so in development, you have well-labeled data in the form of an evaluation set or a golden set. You've got the ability to establish baseline performance on this labeled data. You can understand whether your agent or agent network has performance degradations, so regressions, and you can do this in a deterministic and repeatable way. Unfortunately, this requires labels, and this doesn't necessarily apply when you go to production. The output of this development process is that you can improve your agent's performance and deploy it in production. And then once you land in production, you can use the tools that we've developed on Okareo, so that's traces, monitors, and checks, in order to evaluate unseen production data, in order to detect error modes that you haven't previously encountered. And you can do this using dynamic LLM-based checks, and you don't need to know a priori what labels are necessary. Once you get some new unseen errors in this production setting, you can actually pipe this back into your development workflow, and you can label that production data and add it to your golden set. So the choice of the evaluation type really depends on your needs, and both have their place as they feed into one another, sort of like a powerful flywheel that can help improve your agent's performance. Thanks so much for watching today, everyone. If you have any follow-up questions about using Okareo to evaluate your agents, then feel free to reach out to me directly. This is my email address. It's just my name @Okareo. And if you're ready to get started with tracing and evaluating your agents, then go ahead and go to okareo.com and sign up and try us out for free. I hope you have a great day. Thanks so much.